Welcome to the first of the videos for Introduction to Engineering and Computer Science. This would be a sequence of topic-specific videos tracking the textbook very closely, the Introduction to Engineering and Computer Science. You can find this textbook at the URL engineeringcs.com courses/Engineering 120 lectures intro. Probably the easiest way would be if you have the course canvas, just click on the material and it will take you there. So the topics we're going to cover today is kind of overall, it's called education and careers. This is the chapter 1 introductory material, to giving you kind of an overview of what a computer science field and engineering field, electrical engineering field, the related fields kind of end up doing when they're out there. What are the careers? What are some of the processes that are crucial to learn and be good at to be successful in this field? So let's go ahead and start by just walking through some education requirement. In order to be a computer scientist or engineer, you have a certain educational requirement. And here is this chart tries to give you an overview of the different levels of education you can get in this field. Now, for example, for this one, I have broken it down to 2-year intervals. So let's assume we start at the bottom of the picture right here, where we are just graduating from high school, and we are trying to decide what we want to do. Of course, one of the options would be just to go to work. And the issue here is that more or less every time you get one of these degrees, every time when you get an associate degree, your potential income doubles. And the contribution level also doubles in a sense. When you get a bachelor's degree, doubles again. But once you go above a bachelor's degree, that incremental benefit you get from your education in terms of income, at least, goes down, doesn't increase. Maybe there's a 10% increase when you get a master, maybe no increase, or maybe another 5% if you get your PhD. So when you get out of high school, for example, if you come to Clark, you're taking a class at Clark College, which means you're going to do your first 2 years at Clark, get something called an associate's degree, depending on what your major is. If it's computer science, that would be associate in computer science. If it's not, it's going to be in computer engineering or electrical engineering. And then you typically will transfer to a school, one of your choice of 4-year degrees. You would have 2 more years there, and you get your bachelor's degree. Okay. Now, after that, most people go to job. And this is probably, I would say, the optimum place in terms of the education you need and the job you need is to at least get a bachelor's degree. If you want to continue to master, you really need to have a reason why you want to do that. Usually you want to specialize in an area or something like that. From entering the job market, bachelor's is probably the optimum place to come in terms of the type of interesting jobs you can get, in terms of income you can generate and things like that. But if you're interested in teaching or research or whatever, you can continue on and go up here to a PhD, which is the highest level of education you can attend. So now we've talked about the education side. There's also another thing to consider. When you go to the industry, you can work for one of these sectors. You can work for a commercial, like Intel's, Microsoft's, NVIDIA, Google, or any of the local companies here. So you can, those are we call commercial organizations. Or you can work for government. You can go work for social services, or you can work for Bonneville Power, or any of those people. And that would be the government. And then education, of course, like what I'm doing here, teaching a class, that would be kind of role in education. Or you can go to military and serve as someone in the military who's working for the defense and doing that. You apply your engineering skills or computer science skill to that. Typically, so the arrow indicates the pay level goes up as you move up. As we said, it pretty much doubles from high school to associate, from high school to bachelor's, but maybe goes up another 10% if you get a master, maybe another 10%, or maybe not if you get a PhD. You get a PhD because you want to be a researcher, not because you're looking for improved job prospects. Actually narrows your job prospects quite a bit. And if you work for military, they have really, really good benefit, but the salaries are pretty low. Commercial has the highest salary, and then the rest just fits in between. Okay, so those are kind of overview of both from an education point of view and the type of companies you'll end up working for. Okay, so let's say what would I do? So if you come to Clark, the classes are pretty much very well defined. And at this point, I would really, really encourage you, if you haven't already done that, to visit this website, to visit let me see if I can write that here. Visit engrcs.com/schedule, all small letters, okay? The word schedule. And if you go there, so let me just go there, you'll see that there's a bunch of faculty advisors who are more than happy to meet with you and develop an education plan. So if you haven't done that, this is really, really important to do it very early on. And oops, I must have typed something incorrectly. So engrcs.com/schedule. Okay. And then let's go to a week, so it's easier to see. And you can see there are different people that be here. Nick is the other person who does the computer science and engineering. We also have advisors for mechanical and civil, if you're interested in those fields. And their schedule will be on this calendar, and you literally can, there's Zoom, so you can just click on the Zoom meeting and join them during those times. And if not, you can email them, and most of us will set up a time if you cannot meet during this time. So that's really an important thing for you to keep in mind as you start your life. And typically, the courses you got to take has to do some social science and humanities, some math class, lots of math classes, bunch of physics, a whole year of physics, a bunch of computer science and engineering, depending on which degree you're going to. And so those are the courses you take here. And then why folks come to community college? There are many reasons. Community college be proven to be successful. Most of our students who transfer from Clark to university typically have a higher GPA, higher grade point average, and more successful in the courses than even the people who went the first 2 years to university. You have smaller class size. There's a significantly lower, usually a third of the cost of going to a university. Most people are local, want to stay local. And then we do a lot of hands-on projects when we are together. So those are kind of some of the reasons people go to a community college instead of directly going to university. Some of the universities that you may want to consider: University of Washington State University in Vancouver is probably optimum university, unless you have a good reason to go someplace else. That is the best place to transfer to. But there are others. There's Portland State, which is local. University of Washington in Seattle. University of Portland, it's a private school. Oregon State is a little farther. Washington State University Pullman is a little bit farther from here to join. But these are some common places, but we have had students go everywhere in the country. That's fine. As far as the career is concerned, yes, you're studying to be a computer science, electrical engineering, computer engineering major, but that just doesn't tell the whole story. What happens is that first 2 years, most of the courses are common. You're building a foundational plan. But once you go to your third and fourth year, junior and senior year of college, you become specialized. So for example, you could have an electrical engineering student who's focusing on energy systems, power and energy systems, and their curriculum is going to be significantly different than someone maybe who is working on, let's say, semiconductor, or someone who's working on biomedical side of things. So so for the first part, we are all doing the same thing. If you're in electrical engineering or computer engineering, doesn't matter, or computer science in that sense. So the first couple of years are very similar. There are some differences, but they're very similar. But as you go to your junior and senior year, you could specialize. You could be a computer science major one person works on embedded system, another person might be working on, let's say, game development, and their curriculum would be, again, once again, significantly different from each other, or artificial intelligence or something else. So it varies. And once you did, the interesting thing is once you get to the industry, and you ask people what you're doing, they no longer say, they might say they are a computer science or electrical engineer, but they most of the time, they identify their position, the companies identify their position depending on where they are in the development cycle of the product. So products usually start from somebody decides, hey, we need to do, our customers need something we don't have, so we should create something. Then they try to design it, then they try to build it, then they test it, and then once they test it, they find out something is not working, so they go back to the cycle. This is called iteration. So you go back, fix stuff, then come back and test it again. Hopefully then everything is good. You start producing it and marketing it. And then once you're marketing it, the customer have it, you have to sell it to the customer, and then you got to support it. So you can have, so there are jobs like called design engineers. That means their job is in here. It's really not saying I'm a mechanical or electrical engineer or computer science. They say I'm a design engineer. So sometimes you see kind of people companies identifying their employees based on which part of this cycle they end up in here. Okay. So those are kind of the careers. If you hear the words, hopefully that now makes a little more sense of what they mean when they're talking about if somebody's a manufacturing engineer, or somebody's a sales engineer, or support engineer, or design engineer, what they're referring to. Okay. So those are kind of the career stuff. A lot of time I've had folks ask, hey, what is the difference between electrical engineering, computer engineering, and computer science? And then I would even go as far as add one more thing, one more kind of circle to this thing. And they are indeed related to each other. I would also put like physics, chemistry in here as well, more physics than chemistry and biology, but more and more these are becoming relevant. Chemistry and biology are becoming relevant, but physics is really the biggie. So if you think about it, let's take computer science and electrical engineering. Our job is we work with things that are basically are taking advantage of electrons and the properties of electrons. Electricity is made because electrons move and they have properties, therefore we have that. So physics folks are mostly not interested about applying it, but rather understanding what the natural phenomena really is. How does an electron behave? So when you take a class for physics, they're not interested about building anything or building a circuit or building a computer or programming a computer or anything like that. They're more interested about how electrons behave, how can I describe how nature works and things like that. Electrical engineers, on the other hand, is how can I take the ideas that physics folks had discovered in the nature and put it in use, okay? So let's say physics folks know electrons move, that creates current, and these folks figure out, oh, I can take that and build a transistor, which is an electronic switch, and then build chips and build motors and build sensors and things of that nature, how to use it to generate power and all of those things. And then a computer engineer basically is someone who basically takes those components and tries to put it together to build something. So for example, if you work for an Apple, this is the person who, when they want to design a new phone, this is the person who once puts the components together and then writes enough program to make it so programmers can start writing application on top of that. So if you want to think about it, these are kind of the core software and apply, they take parts from the electrical engineering and create the digital systems or computers. Phone is really a computer as well. And then computer science folks is mostly folks who'd really rather not know anything about the hardware. They don't want, they will be completely divorced from hardware. They want to be able to make calls to certain functions, a certain underlying infrastructure that does the job for them. For example, in here, let's say I'm going to write an application to locate myself in the world. And so these folks created the GPS signaling back and forth and identifying geolocations and things like that. These folks built it into the computer. So now there's a call which says get location and comes back with the value. And then the job of the job of computer science folks is to get that underlying information and manipulate it and present it in a way that makes sense to the user. So those would be, it's a bit of a caricature, but that's about how the three fields are related to each other. Now, having said that, it's not very uncommon to see these people move up and down. It's really rarer to see computer science people moving in this direction, but you'll see electrical engineers programming, computer engineers programming, and sometimes going all the way up to applications. And now, depending on how big a company do you have and how much resources do you have to apply. Sometimes if you don't have enough people, so the same person will do different things. They are different fields, but you do see people moving between them. There's a little bit of a fluidity when you actually get the job of what you end up doing. This one is a kind of it's a thought exercise. I thought I put this in here. It's good for you to do this. It's just kind of think about, okay, if I think back in the last, let's say 10 years, what has been some of the great achievements that have happened? Maybe this is 10 years. 10 years would be nice to think about it for yourself, because you've been around at least for the last 10, 20 years. So think about, what do you think are some of the biggest inventions? What were the drivers on it? Who was the players? So here's like, I took this from just thinking about it. You have like 10 to 1 kind of doing it. It's just a backward, one being the most important thing. So you can kind of see pretty much this is accepted that in the last 100 years, the biggest invention has been the fact that now we have easy and safe drinking water. Humans, I mean, you got to meet some basic needs before you have time to kind of explore and advance. So once agricultural mechanization, air conditioning, and refrigeration, when 1, 2, 3 was taken care of in the last 100 and some years, then we didn't have to worry about the basic sustenance. Food was always available, if you had the money, of course. And then water was always available. You didn't have to think about it. Then you could start looking at creating higher level functionality, higher things. So electronic and computers, communication, transportation, health and medical technology, genetic and bioengineering, high performance materials, space exploration. So this was, you can think of it, this is my 10. My 10 doesn't have to be end all. You could have your own 10 and justify that. That is the biggest thing that have happened. And if you want to do an exercise, it would be interesting for you to think about, okay, what are some of the big things that are going to happen in the next 10 years? They're probably not going to be, that could be as fundamental. Maybe you sit down and think about it and say, well, AI is going to probably play, artificial intelligence probably going to play a much bigger role, human assist in all kinds of fields. Maybe you think a driverless car will be available within 10 years. Already Tesla has some form of it. It's not quite driverless. You still got to be behind the wheel, but that's maybe happening. Maybe we get to the place where medicine, instead of going to a doctor, would be AI based, or I don't know. I don't just sit down and think about it. And why is that important? That is important because you're stepping into a career. You make a career decision. It would be nice if you were in a field that you felt like was going to be the big contributor into the future. So as opportunities are greater when there is more growth available. Here are some benefits of engineering. Some of the pretty obvious stuff. Definitely, I can't think of any field that doesn't need computer science and engineers. I just can't think of any useful service or product that is out there that doesn't need the support or enablement that comes from computer science and electrical engineering. The work is intellectually challenging because if somebody knows how to do it, they don't need you and I to do work on it. They only work on things they don't know. So a lot of time, we are called problem solvers. That's what we are. We try to take a problem that exists and apply our knowledge in engineering or computer science to solve that problem more efficiently than even if it's done already, we want to do it more efficiently. And it's definitely is a very satisfying job because you always are adding value to the society, not to mention that financially it's pretty rewarding, this field that you guys are thinking about going into. Okay. It's really important as early as you can to get into groups and societies. Right now, we don't have, with the COVID and remoteness, we might not have the club running right now, but in the future we'll run it. There are other clubs like, they're not clubs, institutes, such as IEEE and ACM that play a pretty important role. And I would actually caution you that you don't have to be in a formal club or a formal group. It just could be a group of you guys getting together and working on stuff. You could be participating in some of these opportunities that are available online to work on projects. For example, Google has a summer of code that you can participate in for coding. There are these groups who get together and try to design a new product together over a day or two. So there are lots of great opportunities there. This doesn't really apply to us as much, but I just want to let you know, once you get your bachelor's degree, you have an opportunity to do a professional engineering certificate. This is usually important if you're going to be working on a public safety device. Then you should have PE certification is important to have. Most of us will not be working on things that would kill somebody because bad, but if you're working on something that, then you probably should have a PE certification. I wanted to kind of present this model also as in this one kind of in this overview we're going through. I wanted to also present this idea where it's always good for you to kind of think about where you're going in the long term and then make short-term decisions based on what is really, which one is going to get you closer to you. Let me give you an example. Let's say all of us are a student in the first year of computer science or engineering field. And our goal is to be a professional in a commercial, in some industry, in some sort of a computer industry or in the electrical engineering industry, right? That's our goal, let's say in 4 years to be there. Now, let's say you want to do some part-time jobs, and you're given you have two opportunities that pop up, and I don't mean to pick on McDonald's, but let's say one opportunity is to be a server in McDonald's. Another opportunity maybe is an opportunity to work for locally, let's say for who's local. Let's go ahead and work for Hewlett Packard. Okay, so those are the two options you have. A McDonald's, because they have a shortage of employees, they're willing to pay you $20 per hour. These guys, you're an intern, so you maybe they don't, and they're gonna give you $15 an hour. Okay, so if you don't have this goal, long-term goal that you want to be a professional in the field of computer and electrical engineering, you may think, hey, this pays me $5 more. I should go here and work for these people. But then if you think about it a little more, you say, wait a minute, I'm probably better off going to work for a technology company because I want to be a professional in the technology field. So if I'm here, I get exposed to other people who are currently engineers and computer scientists. I may have an opportunity to move into a better job while I'm working with them, because when you're there inside rubbing shoulder with those people, opportunity comes up. Who do they give it to? They give it to the people who they know. So the reason I have this thing as a straight line, but I show these different states as kind of being offside, is this initially look like if you want to go there, you might as well beeline it, don't do anything but study till you get your degree. But in this case, you're doing some work and you may decide to take this Hewlett Packard job, which pays maybe a few dollars less per month, per hour, and not go for the higher pay, because even though it seems like a good deal initially, this might be a better deal in the long term because it gets you closer to your desired goal. Okay, so this is a good exercise for you to do. Just sit down and think about where you are today, where you want to be 4 or 5 years from now, and what can you do in the next year to get you closer to that, besides going to school, of course. Okay, so this is a model that I feel is called the, present state, is current state, desired state model. And I would encourage you to sit down and maybe spend 10 or 15 minutes. It's a good exercise for you to do this. Okay. So these are the kind of introductory overviews that I wanted to cover in this video. Now, at the end, you will have to end up doing some homework, or not homework, but just some evaluation of whether you got some of this information or not. And so let me go ahead and bring that up as well. So there are questions here just to have you exercise some of the things you've learned or in this section. It says use the job listing service online to find 5 open positions that interest you. Why is this useful? It's useful because it gives you an idea of what the name of those jobs are. It gives you a little bit of an idea of who is offering those jobs, a little bit about what they require, what kind of skills, what kind of questions they want you to know. Now, the question is to say, I don't know who's hiring, but the nice thing is there are a whole bunch of groups. I think there is like a Glassdoor. Glassdoor is a good site, and you really don't have to limit yourself to jobs in Vancouver. You can go to Glassdoor and find out what jobs are available there. Monster is another one. If you haven't done that, the other thing that's really useful is LinkedIn. If you're not a member, this is a professional kind of a Facebook for professionals, if you will. And you kind of do a little description of who you are. And then they have jobs and all that are posted there, internship and other things that you can explore. So anyway, there are many, many sites. So you can maybe go to one of these sites and try to figure out if there is anything that interests you. Kind of brainstorming what you think are the top 3 problems that you would like to solve, you would be interested to solve, that would be doable in the next 10 years, just brainstorming. Just another kind of brainstorming of areas. There's no correct or right or wrong answer. It's just for you to think about it. We went through a whole list of specialties. Now name 5 of them just to kind of get you thinking about what those are. Develop a 5-year plan. That was the current state and desired state, where you are, where you want to go. This one, make sure that you have done a academic plan. This you do in conjunction with one of the academic advisors, and then just kind of brainstorm what groups or associations or things you can get together with to enhance, complement what you're doing in a class. Okay, so this video was just kind of getting you started, giving you an overview of the career education, some of the things you can do to set yourself up for success as we move forward. That brings us to the end of this video. Thanks for watching.